Let's go with Sammy G. What'd you get for number 1? Parallel. Pick somebody, Sammy. Angela, I have a question about number 1. Since they are parallel, how many solutions would they have? That is correct, 0. Pick somebody. Haley, what would you say for number 2? Perpendicular. Why, Haley? Good vocab, opposite reciprocals. Pick somebody. Sydney. There you are. Sydney, on number 2, how many solutions would they have? That is correct. Sydney, pick somebody. Who was this one? What'd you say? How did you get that? The slopes both ended up being 2. You mean you solved for a letter? You are the first one today that I've called on. And I didn't call on you, obviously. Sydney called on you, right? First one today to get it right. You're the first. That's fantastic. Now, I actually came up with another way to do number 3 that's a little tricky, a little sneaky. You want to see it? Mainly because I didn't want to have to solve both equations here. So what I'm going to do is move that off to the side first off. But if I was trying to do elimination, and I know we haven't talked about elimination yet. We'll talk about it tomorrow. I'm going to multiply that top equation by, normally by -2. I'm actually just going to multiply it by 2. Okay, so if I multiply the top equation by 2, I get 4x minus 6y. Hey, look, that's exactly the same so far, isn't it? Equals 18. So that number at the end is different. So if all the other numbers except that number at the end are the same, then it's parallel. What if for some reason I multiplied and it had equaled 10? Then what would the answer be? Infinitely many solutions. Good. Okay, so that one was tricky. You can't just say neither because that was a word you hadn't used yet. Doesn't work that way. Does that make sense? I want to show you right now how to use your calculator, though, to solve number 2. I'm going to show you how to use the calculator to solve number 2. So the first thing we have to do is open our calculator. Just like you guys, I have to open mine too. And we're solving by graphing so far, right? So I'm going to go to my y equals, and I'm going to write both equations from number 2 in there. And I'm just going to pause for a second while you guys type these in. All right, so you type this in. I'm going to go ahead and hit graph at this time. And now I can look on mine. If you look close at mine, you can actually see that it meets right here. But it's not at a perfect crosshair, is it? It's not. So if I tried to graph this by hand, I'm not going to be able to guess the actual answer. But our calculator can give us the answer. Here's how. We click on the second key, and then we click trace. And if you don't know which one's trace is, it is highlighted up here in red now for you. And I'm going to go down to the one that says intersect and click enter. So for me, that's number 5. And I'm just going to use my left arrow a little bit. I was a little too close to where it crossed, and I don't like that. So here's my first curve. And I'm just going to click enter. And then it jumps. Here's the second curve. You see how it's on a different line altogether? Now it says curve because you can actually find where a line meets a parabola. You can find where two sine graphs meet and so on. But I just click enter on the second curve. And then it says, can you guess where it is? Where do they intersect? So I'm going to use my arrow keys a little bit. And I say they meet about there. You guys agree? And I click enter. Go down, click enter. And then it figures it out. And down there at the bottom in red on mine says 2.7, negative 3.1. That's where they meet using the calculator. Come on up, Jacob. Let me look at it. So here's our next daily warm-up. I chose 2 warm-ups. I actually shortened this lesson into 2 days instead of just 3 days because you guys are so good at graphing. I tried to cut a day out. So the last daily warm-ups were more like problems you were going to see on chapter tests, on the next quiz, things like that. Where this problem, SAT. SAT. I told you in this class I don't want to just make you good at Algebra 2. I want to make you good test takers. I want to make it so that when you go and take the SATs, you get whatever score you want to get into whatever college you want. That's fair, right? All right. Come on up. Let me look at it. Raise your hand if you think you know the answer to this. I want to see how many hands I get up first. Good. Okay. Raise your hand if you want to. You put a minus sign. There you go. Raise your hand if you want to tell me the answer. Ooh. Let's go with Josh. I don't hear much from Josh. What'd you get? 12 is right. 12 is right because all you do is plug that negative 2 in for the yin-yang symbol. Now, instead of them using the variable x, they used a symbol. On the SATs, they don't like to use m of x or f of x like we do. They like to use f of star, f of smiley face, f of frowny face. They want to use a symbol and make sure you just understand the notation. Does that make sense? Raise your hand if you got it right. Good. Lovely. So I don't want you to be frightened if you see that on the SATs. All right, now that you're still in that spiral notebook, turn to the front into your table of contents and copy down your objective. So here's our first word problem. And like I just told you, but I didn't tell the people in the audience here that they're listening from home, we are just going to learn today how to set up a word problem. How do you attack a word problem? If it's on the PSSA, say FCAM, Florida. If it's on the Keystone, if it's on the SATs, how would I attack this word problem? And the first thing you should always do, anybody know? Yeah, normally I would say write down the key information, like if you're writing it out of a book. Hey, but we've copied it right into your notebook, so just underline the key information. Go ahead and do that. All right. Who have I not talked to today? Let's go. Tanner, give me one piece, just one of key information. Lovely. Pick somebody. Lovely. Pick somebody. Lovely. Pick somebody. Wonderful. So, now that we have the key information, the next thing we do is we figure out what we're looking for. What am I looking for? How many adults and children bought tickets, right? So there's actually 2 separate things I'm looking for. I'm looking for, I'm going to call this my variable. I'm looking for adult tickets. And I'm looking for children tickets. Now notice I was specific. I didn't say how many adults and how many children. I'm looking for how many adult tickets, how many children tickets. Does that make sense? Okay. What letters do you want to give them? It has to be a variable. Okay, you could use X and Y. I'm I'm not the type of person to use X and Y. But if you want to, it is not wrong, Noah. In fact, it's 100% correct. Let me show you what you could use, and then I'll take what you guys want to use instead. Okay? I could use I could use symbols if I wanted to. A big stick person for adults and a little stick person for children. I could do it that way, right? I could use X and Y. But what do you guys want to use? A and C. I would be using A and C. But Noah, if you use X and Y, that's fine. And here's how I'll know which one's X, which one's Y. You're going to write this out. Okay. Any questions so far on the variables? Okay, now we get to the next step. We write equations. Now I have two variables. That means I need to write two equations. Discuss in your group and see if you can come up with one of the two equations. Let me have the attention back up here because I'm pretty impressed. I'm listening and I'm hearing a lot of people saying 4C, 7A. Raise your hand if you said that somewhere in your group. Somebody said it. Okay, you guys are right. So I'm going to write that 4C, 7A equals 4. What's 4 represent? 4 cows? So money, right? And 7 is, so what's my money amount I'm going to put over here? Notice these three things have something in common, right? Money, money, money. In order to write an equation, they all have to have something in common. They all have money in common. What are we going to put between those? A plus sign. Think of Mrs. Ackleton when she takes money for the variety show. Doesn't matter if you're a student, adult, you bought it before, if you bought it after, whichever. She adds all that money together, right? Okay. Well, I thought one number left. 575 is my last number. Well, can I multiply adult tickets and children's tickets? What would you do with them? Add them. So C plus A equals 575. Here's why. C stands for children's tickets, right? A stands for adult tickets. And 575 stands for 575 tickets. What do they all have in common? Notice how they all had that in common, didn't you? Does that make sense? Everybody see where those numbers came from? Pretty easy? I told you today we're only setting them up. You set up your first one. I'll teach you how to solve these, whether it's later this week, okay? So what I want you to do right now is to flip your page over, because you need room to solve that first equation later this week. And I want you to paste in the big one now. So here's our next problem, and you guys are pasting it in. After you paste it in, what's the first step you guys have to do? Good, go ahead and underline the key information. So, we found our two variables, student tickets and adult tickets, and we've highlighted our key information. What's our third and final thing we need to do? Write the equation. Take 20 seconds if you haven't already. Write your two equations. And then, let's have if there's two people in the middle, I'd like the youngest of the two to share their two equations. Because they haven't talked yet, I believe, in the group. The youngest of the two. All right. Let me have your attention back up here. Let me have your attention back up here. And I I'm actually going to show you what I wrote down. Now, if I could write near as neat as Kinsey can, then I wouldn't have to worry so much. But my S's look like my 5. I'm going to guess that Kinsey, her S's look like S's, her 5's look like 5. There is a flat difference between them. On mine, they look the same. So I do mine a little differently. I'm going to write 1.5 S. Now put my S in parentheses because it's touching a 5. Raise your hand if you put 1.50. Does that mean a difference? Could I have wrote 1.50000000? Sure, that's kind of crazy, but okay, I can do that. Jake. How about 3 halves? Because this is 1.5. That would work. Okay. And plus 5a equals 3,200. Raise your hand if you had that equation. Very good. And then the other equation I had was S plus A. This time I didn't put the S in parentheses. It's not touching a 5, so I can tell the difference. Equals 1,200. Raise your hand if you had that one. Lovely. So, I'm not worried today about solving these. I will worry about them later this week, though. Sound good? So, I'm going to have you practice this a couple times along with the graphing again. Here is your essential work due tomorrow.